Hi children, how are you? I am very fine. Thank you. Today we are going to learn about the second part of revision in sets. So children, already we learned about the definitions of sets in first volume. In that we have showed some group of birds which is not a set. It is only collection of objects, and definition of set and some definitions on the sets. Now we are going to learn revision about operations on sets. What are the major operations? Fundamental operations on sets are majorly union and intersection. So now we are going to learn about union and intersection. What is the union? Union of two sets or three sets, and intersection of two sets or three sets, whatever it may be. So union means you have to write all the elements in the both sets without repeating the elements. That is union. So let us see what is union and how to write union of sets. If A and B are any two sets, the union of A and B consists of all the elements of A and all the elements of B. The common elements written only once. The symbol U, union, is used to denote the union. Symbolically, we write A union B and read it as A union B. So now we are see one example to learn the union of sets. Okay. Now given in the problem, let us see the example. If A is equal to set 3, 6, 9, 12, 15 and B is equal to 4, 8, 12, 16 and 20. C is equal to 2, 4, 6, 8, 10, 12 and 14. Now we have to find A union B, A union C, B union C, A union B union C. We have to read the whole as in the bracket as a one word, that is A union B union C. And here, and fifth one is A union B union C. So read like that. Now we are going to find the values of A union B and whatever it may be they asked. So given A is equal to set 3, 6, 9, 12, 15 and B is equal to 4, 8, 12, 16, 20. Now A union B is equal to, you write A 3, 6, 9, 12, 15 union and set B 4, 8, 12, 16 and 20. Now write the first set elements 3, 6, 9, 12, 15. Now observe what are the repeating elements, they don't write, and remaining elements you have to write. 4, it is not repeating in that elements. 8 is not repeating, you write. 12 is already written there, so you need not write 12 again. 16, you write 16 because it is not repeating. 20, you write it. So the elements are arranged in order, then we get 3, 4, 6, 8, 9, 12, 15, 16 and 20. So this is A union B. Very, very easy to find A union B, isn't it? Now let us go to next question, A union C. How can we find A union C? Again you write A, the set of elements A 3, 6, 9, 12, 15 and set of elements C 2, 4, 6, 8, 10, 12, 14. Now write 3, 6, 9, 12, 15 as it is. Then in second set, that is C, write the elements which are not repeating in the previous set. So 2, it is not repeating, you write it, and 4, you write it, 6 already written in that 3, 6, 9, 12, 15, that is in set A. So need not write 6 and write 8, 10, 12 is already there, no need not write, and 14. So arrange the elements in ascending order or in order. We get 2, 3, 4, 6, 8, 9, 10, 12, 14, 15. So that is A union C. Then go to B union C. Here B is 4, 6, 4, 8, 12, 16, 20, and C is 2, 4, 6, 8, 10, 12, 14. Now B union C. Very good. Write the elements in B. Set 4, 8, 12, 16, 20 union, and write the elements in C. Set 2, 4, 6, 8, 10, 12, 14. First you write all the elements in set B, first set, that is 4, 8, 12, 16, 20. Now go to second set, write the elements which are not repeating in the previous set. Write 2, 4 is already repeating, so 6, 8 is there, 10, 12 is there, write 14. So arrange them in order 2, 4, 6, 8, 10, 12, 14, 16, 20. So this is the B union C. Now go to fourth question. A union B union C. Already A, B, C sets are there. A union B union C. Now we take B union C from the previous answer. Already we calculated B union C. So write A 3, 6, 9, 12, 15 and union of already we calculated in question number 3 B union C. We take it as granted. So that is 2, 4, 6, 8, 10, 12, 14, 16, 20. Now write the elements in first set 3, 6, 9, 12, 15 as it is. Then go to second set, write 2 because it is not repeating in the previous, and 4, 6 is repeating, leave it, 8, 10, 12 is repeating, leave it, 14, 16, 20. So arrange them in order 2, 3, 4, 6, 8, 9, 10, 12, 14, 15, 16 and 20. So these are the elements A union B union C. You read it as A union B union C. B union C is a single word that you read like that. And again go to now A union B union C. Now take A union B from first question. So A union B is already calculated in question number 1. So that's why we take it as granted 3, 4, 6, 8, 9, 12, 15, 16 and 20. Union. What are the elements in C? Write it as 2, 4, 6, 8, 10, 12, 14. Now write the first set elements as it is 3, 4, 6, 8, 9, 12, 15, 16, 20. Now 2 in the second set. It is not in the first set, so you write 2 as it is. And then 4 already written. 6 already there. 8 it is already there. 10 already not in the previous set, so you write 10 here. 12 already there. So 14, you write 14 because this is not in the previous set. Then arrange them in order. You get 2, 3, 4, 6, 8, 9, 10, 12, 14, 15, 16 and 20. So this is A union B union C. Observe that A union B union C and A union B union C both are same. Observe the two sums. The answers are same. That means you can calculate in any way. This is known as associative law. This is more information. This is associative law. So now let us see one more example. Now given two sets in set builder form, we already learned about how to convert builder form to roster form. So that's why we take it as if A is equal to set of all x such that x is a prime number less than 10, and B is equal to set of all x such that x is an odd number less than 10. Then find A union B and B union A. Now take it A is equal to set of all x such that x is a prime number less than 10. What are the prime numbers less than 10? Yes, you are right. 2, 3, 5, 7. And what are the elements less than 10 odd numbers? That is B. 1, 3, 5, 7, 9. Now we have two sets in roster form A and B. Now we are able to calculate A union B and B union A also. Now how can we find A union B? Right, A union B, first set A, that is 2, 3, 5, 7 union, and second set B, 1, 3, 5, 7, 9. As we know, write all the elements in first set as it is. So 2, 3, 5, 7. Then go to second set. 1. It is not repeating in the previous set. So you write 1. 3 already there. 5 already there. 7 is there. Now 9, it is not in there. You write 9. Arrange them in order. We get 1, 2, 3, 5, 7, 9. So A union B is equal to 1, 2, 3, 5, 7, 9. Now go to B union A. B is equal to 1, 3, 5, 7, 9. First you write B set because B union A we calculate. And then union A, 2, 3, 5, 7. As our norms, first you write all the elements in first set. That is 1, 3, 5, 7, 9. Then go to second set. 2. It is not in the first set. You write 2. And 3 is there. 5 already there. 7 already there. No need to write no more elements from A. So you have 1, 2, 3, 5, 7, 9. Observe that both A union B and B union A are same. Both are same. So A union B is always equal to B union A. We can conclude that A union B is always equal to B union A. Similarly, in the previous example, we can say that A union B union C is equal to A union B union C. Both are same. This is A union B is equal to B union A commutative law. And A union B union C is equal to A union B union C is an associative law. So sets follow these two laws, commutative and associative laws. Remember these points. This is more information about this calculations. What we have observed in the above two examples, some elements are common in both sets. Then we write all the elements which are not in common and write common elements only one time. That is how to write union. This is one case. Some elements are common in both sets A and B. Now let us take another example. If A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 3, 4, 5, 6, then find A union B and B union A. It is very easy to find out. So A union B is equal to, again we write 1, 2, 3, 4 first set, union 1, 2, 3, 4, 5, 6 second set. Now write first set elements as it is 1, 2, 3, 4 and go to second set. Already 1, 2, 3, 4 are there. You need not write again. Then go to 5, write 5 and 6, write 6. So it represents the set B. Observe that all the elements are equal to set B. So now here A union B is equal to B. These both are equal sets. Already we defined about equal sets. If two sets having same elements, then we call them as equal sets. Now here A union B and B are equal sets. Go to B union A. Write B 1, 2, 3, 4, 5, 6. Union 1, 2, 3, 4. Write first set elements as it is 1, 2, 3, 4, 5, 6. Go to second set. 1 is there, no need to write. 2 is there, 3 is there, 4 is there. There is no need to write another element again. So that's enough. That is equal to B. So B union A also equal to B. So if A is subset of B, you observe that here all the elements of A are in B. Then we call it as subset. A is subset of B. Already defined that. So A is subset of B, then A union B is equal to B always. Which set is greater? It represents A union B. Remember this point. Suppose A and B are two sets. B is subset of A. Then A union B is equal to A. Which set is a larger set? Which is greater set? Which has more elements? That set represents union. So A union B is equal to here B. This is second type. In first type, only some elements are common, not all elements. In second case, all elements of A are in B, that is subset. This is second case. Now go to another case. A is equal to set 1, 2, 3, 4 and B is equal to set 5, 6, 7, 8. Observe that all the elements are different in both sets. Now find A union B and B union A. Write A union B. That means first set 1, 2, 3, 4 union, second set 5, 6, 7, 8. So you write 1, 2, 3, 4 first set elements as it is and go to second set, write 5 because there is no 5 in first set. Similarly 6, write 6 and 7 and 8. All the elements are not in the previous set. So we can write all the 4 elements in B as it is in A union B. So here we write all the elements in A and in B. So similarly we can find B union A. First you write B 5, 6, 7, 8 union A 1, 2, 3, 4. Again you write all the elements 5, 6, 7, 8. Because 1, 2, 3, 4 are not repeating elements, you write 1, 2, 3, 4. So then B union A is equal to, after arranging in order, we get 1, 2, 3, 4, 5, 6, 7, 8. That's why we generalize if two sets are disjoint, then we write all the elements in A union B. If A and B are disjoint, then write all the elements in A union B. So we observe here 3 cases. In case 1, some elements are common in 2 sets. In case 2, one set is subset to another one. In case 3, no element is common for both sets. These are 3 cases arrived in finding of union of 2 sets. All the 3 cases we know. That's why we are completely learnt about A union B. I think you are now able to do any problem to find A union B. Now go to another concept, intersection of sets. How can we find intersection of sets? Intersection of 2 sets means simply you write common elements in both sets. That's enough. If there is common element, you write that's common elements only. If A and B are 2 sets, then the intersection of A and B consists of all the common elements of A and B only one time, not repeating. The symbol intersection is used to denote intersection. Symbolically we write A intersection B and read it as A intersection B. So observe the symbol and how to write A intersection B. Now go to one example. Already we take the same example in union example. A is equal to 3, 6, 9, 12, 15. B is equal to 4, 8, 12, 16, 20. And C is equal to 2, 4, 6, 8, 10, 12, 14. Then find A intersection B, A intersection C, B intersection C, A intersection B intersection C, A intersection B intersection C. We have to find the 5 problems. So go to first one. We have to find A intersection B. What is given? A is equal to 3, 6, 9, 12, 15. And what is B? 4, 6, 4, 8, 12, 16, 20. Now A intersection B is equal to set 3, 6, 9, 12, 15 intersection 4, 8, 12, 16, 20. Now what are the common elements in both sets? We find that only 12 is the common element in both sets. You write simply 12. That represents A intersection B. That's enough. It is very easy to find A intersection B. Now go to second problem. A intersection C. Again, A is equal to 3, 6, 9, 12, 15. Intersection 2, 4, 6, 8, 10, 12, 14. What are the common elements in both sets? 3 is not in both, 6 is there, and 9 is not in there, 12 is there. You write to 6 and 12, and 15 is not in B, C. So you only 2 elements, 6 and 12. So this is A intersection C. Now go to B intersection C. 4, 6, 12, 16, 20 intersection 2, 4, 6, 8, 10, 12, 14. Common elements are 4 is common in both, 8 is common in both sets, and 12 is common in both sets. Remaining are not common in both sets. So you write only simply 4, 8, 12. That's enough. So that is B intersection C. Now go to question number 4. A intersection B intersection C. Now we take B intersection C from previous problem. A is already there, 3, 6, 9, 12, 15 intersection. Already we found B intersection C as 4, 8, 12. So now what is the common elements? 3 not in common, 6 not in common, 9 not in common, 12 is common for both sets, and 15 is not common. So you only write 12. This is singleton set. Singleton set, already we defined singleton sets in first volume. Now again go to fifth problem. A intersection B intersection C. Now we take A intersection B from first problem. We got A intersection B is 12 and C is 2, 4, 6, 8, 10, 12, 14. There is only one common element, 12 in both sets. You write 12. Observe that A intersection B intersection C is already singleton set 12. Now here A intersection B intersection C is also singleton set 12. Both are equal. Both are equal. So we can say that A intersection B intersection C is equal to A intersection B intersection C. So take one more example. If x is, A is equal to set of all x such that x is a prime number less than 15, and B is equal to set of all x such that x is an odd number less than 10, then find A intersection B and B intersection A. Now we write first roster forms. A prime number less than 15 means yes, 2, 3, 5, 7, 11, 13. And second set is a odd number. An odd number less than 10 is 1, 3, 5, 7, 9. Now first one is A intersection B. You write A set 2, 3, 5, 7, 11, 13. Intersection 1, 3, 5, 7, 9. What are the common elements? 2 is not in common. 3 is common in both. You write 3. And 5 is common in both. You write 5. And 7 is common in both. You write 7. 11 and 13 is not common in both. You need not write these two elements. So only 3 elements are there, 3, 5, 7. and go to B intersection A. B intersection A means B is equal to 1, 3, 5, 7, 9 intersection, and A is equal to 2, 3, 5, 7, 11, 13. Now go to first set. 1 is not common in both, 3 is common in both, you write here, and 5 is common in both, right? 7 is common in both, right? 9 is not common in both, leave it. So 3, 5, 7. Now observe that A intersection B is equal to B intersection A. So again commutative law holds here. Associative law holds and commutative law holds our intersection also. Now one more example. What is your observation? In the above two examples, some elements are common for both sets. Then we write all the common elements which are in common for both sets and write common elements only one time. That is intersection. Let us take one more example. If A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 3, 4, 5, 6. Again we take here A is subset of B. Then what happens? Observe here. Find A intersection B and B intersection A. A intersection B is equal to 1, 2, 3, 4 set intersection set 1, 2, 3, 4, 5, 6. So 1 is common in both, you write here. 2 is common, 3 is common, 4 is common. So write all the 4 elements. It represents again A. So here A intersection B is equal to A. If A is subset of B, then A union B represents equal to B. Already we saw that. Here A intersection B is equal to A, which is small set. So if one set is subset to another, then you write A union B is the big set, A intersection B is the small set. Here we write A intersection B and B intersection A is equal to A. That's enough. So this is the simple technique. If two sets are there, one is subset of another set, then they asked A union B, you write simply which is big set, whether it is A or B, you write that. That is enough. That is union. They asked A intersection B, then you write which is small set, whether it is A or B, you write that. That is very easy method to write A union B and A intersection B in bit part, not in the problem. In problems you have to do like this. You have to complete the problem with steps. Okay. Now go to one more example. If A is equal to 1, 2, 3, 4 and B is equal to 5, 6, 7, 8, then find A intersection B and B intersection A. Yes, observe that it is given that both are disjoint sets. Both are disjoint sets. Now A intersection B is equal to, there is no common element for both sets, for A and B. Then you write simply phi, empty set. And there is B intersection A also, there is no common element. So you write simply phi, empty set. If A and B are disjoint sets, then A intersection B is null set. If one is subset of another, you write small set as A intersection B. If both are disjoint, then you write null set. So to find the intersection of two sets have some common elements. One set is subset of the other, and case 3, two have no common elements. These 3 cases are already we examined. So children, remember these points and go through your textbook and take some problems, do these problems. All the best. Thank you. Thank you very much.